Hello guys and girls, ladies and gentlemen. In this video, we'll continue working with the GUI program we started in the previous video, so please make sure you have it. If you don't, please refer to the previous video. On the screen, you can see the program we made last time. One of the issues here is that the buttons are smaller than they are in design mode. NetBeans has some peculiarities that might be quite annoying, yet still, in my opinion, NetBeans is the lesser evil Java IDE for beginners. So to make the buttons have the same size as in design mode, and please don't laugh, we need to pretend that we are resizing the buttons. Let me show you what I mean. If you select the Addition button and move the mouse pointer to the right edge of the selection, you will see the pointer change its shape. If we now click the mouse and move it to the right or left just a little bit, we will see a number inside the yellow rectangle. This number is the current width of the button, which is 75. Now let's release the mouse button and this is it. If we now run this program, we'll see that the width of the Addition button is now equal to its width in design mode. We can now do the same for the remaining 3 buttons, but if you want to know what's actually happening when we pretend to be resizing the component on the form, please follow along. Let's switch to source mode, expand the init components method, and scroll until we see the name of our button, add btn. What you see in this line of code is that the width of the button is being set to 75, and 75 is the number that we saw in the editor when we pretended to be resizing the button. We can also see that there is no such code for the remaining buttons. This is why their widths are defined automatically, depending on the length of the text written on the buttons. Now we can fix the width of the remaining buttons the way we did it for the Addition button, but let me show you another way. Let's switch to design mode and select the Subtraction button. Here below the palette pane, you can see the Properties pane, which currently displays properties of the selected button. There's a lot of properties and you're more than welcome to take a closer look and maybe play with them, but the one we need is almost at the bottom of the list, in the Layout section, and it's called Horizontal Size. If we set it to 75, in source code we will see that the same code was added for the sub-btn button. And if we run this program, we will see that both the Addition and Subtraction buttons now have the same width. Alright, we've spent quite a bit of time fixing the width of 2 buttons, so let's speed up a bit. If you prefer using the mouse, feel free to do so, and if you prefer to change properties of the remaining buttons, there is something that can help you do it a bit faster. If you select the Multiplication button, then hold Shift on your keyboard, and click on the Division button, you will see that both buttons are now selected. And since both of them are selected, we can set horizontal size for both of them at once. And if we run the program now, we will see that all 4 buttons now have the same width. Since we got stuck with making our program neat, we might as well do a couple more things to make it even prettier. First, currently we can resize this form, which kinda looks ugly, so let's make the form unresizable. Also, when the program starts, the form is displayed in the top left corner of the screen, which isn't very convenient. So let's also make the form appear in the center of the screen at the start. We can do both by changing our form properties. To do that, let's select the form. Make sure though that you have selected the form, not something else on the form. To do that, make sure you see the orange box surrounding the form. Also, the Properties pane indicates the component that's currently selected. Make sure it says JFrame. Alright, so we need a property located closer to the end of the list. The name of the property is Resizable. This one. And to make the form unresizable, we need to uncheck this property. To make the form appear at the center of the screen, we need to open the Code tab of the Properties pane. Here. And we need to check the Generate Center checkbox. This one. And now if we run this program, we will see the form appear at the center of the screen while being unresizable. Cool. If you're curious, here's the code that NetBeans added when we unchecked the resizable checkbox in the properties. And this is the code that makes the form appear at the center of the screen. Not super self-explanatory, but it's what it is. The bottom line is that NetBeans adds code to the init components method to reflect the changes that we make in design mode. Now that we are done with design stuff, let's get to code writing, shall we? In the previous video, I mentioned 2 issues that we have in this program. First, there's too much of copy-pasted code, which simply put is bad. And secondly, our program cannot handle invalid input like text instead of numbers, which isn't good either. So let's fix this. First of all, how do we reduce the amount of copy-pasted code? A rule of thumb is that when you have a piece of code that you use more than once by copy-pasting, place that code in a separate method and call that method whenever you need that code executed. In our program, the code that gets entirely copy-pasted is this part, getting the text from the text fields and parsing it into integer numbers. This code is what we can place in a separate method. We have seen a few method declarations throughout this video series, but this will be the first time we actually write our own method. A milestone to celebrate. Yay! So the first question is, where do we place our new method? The answer is it doesn't really matter as long as we place it inside the form A class. How about right after the constructor? Here. A method header in Java must consist of at least 3 parts: return type, name, parameters list. Method header, return type, method name, parameters. If you're not familiar with some or all of these terms, I strongly recommend that you refer to the previous videos, including the basics of programming with C video series, before proceeding with this one. So, return type. A method can return any existing data type, such as int, string, array, etc. In addition to these, there's a special return type, void, that means no return. A void method is a method that doesn't explicitly output any data. And void is the return type that we need for our new method. So let's type void. Since this is our first time writing a method, let's just do it without diving into the ocean of theory. Next, we need to give our method a name. Method names should be short and self-explanatory. A self-explanatory method name means that the name makes it more or less clear what the method does. Our method will take the text from the text fields and convert the text into numbers. But a name like getText and convert to numbers is A, too long, and B, doesn't say anything about the origin or purpose of the text, which makes the purpose of the method somewhat unclear. A better name would be getInput or GetUserInput. These names are shorter and they make it clear that the job of this method is to get data from the user. Finally, we need to specify a list of parameters for our method. For this method, we actually don't really need any parameters, so let's add a pair of round brackets with nothing inside, like this. So we now have a header for a method named GetUserInput. The method takes no parameters and doesn't return anything, which doesn't mean it doesn't do anything though. In addition to a header, any method needs what? Right, a body. And the method body is code confined between a pair of, right, curly brackets. Let's now move the code that we want to delegate to this newly created method from the addition button event handler to our new method. And here it's gonna get more confusing, so let's end this video altogether. Screw it. Just kidding. But it is going to become more complex, so please pay extra attention. If we look at the remaining code inside the addition button event handler, we will see that the variables n1 and n2 got red underlined. And NetBeans is yelling at us that it cannot find symbol. This happened because the n1 and n2 variables are now declared inside the GetUserInput method. And here's a hard rule. A variable declared inside a scope is not visible outside that scope. A scope is defined by a pair of curly brackets. So let me repeat it. A variable declared inside a pair of curly brackets is not visible outside that pair of curly brackets. Since variables n1 and n2 are declared inside the GetUserInput method, they are not visible outside the method, so NetBeans cannot find them. How do we fix this? If we declare n1 and n2 variables inside the addBtnActionPerformed method, they won't be visible inside the GetUserInput method. And we do need these variables to be visible inside both methods. Well, another rule is that a variable declared inside a scope is visible in any of its subscopes. Let me translate that into English. If we look at our form A class, we'll see that it has a pair of curly brackets limiting the body of the class. Because there's a pair of curly brackets, it's a scope. Inside the class, we have other pairs of curly brackets, methods. So the scope of the form A class has subscopes. This means that if we declare a variable directly in the scope of the form A class, that variable will be visible inside both GetUserInput and addBtnActionPerformed methods. In other words, to make a variable visible inside more than one method, that variable must be declared inside a class, but outside any method. Let's try doing that. Let's declare n1 and n2 variables outside GetUserInput method. Like this. As you can see, NetBeans was able to find the variables and is not yelling at us anymore. However, now it's grumbling at us with a warning that local variable hides a field in GetUserInput method. The problem here is that we now have two pairs of variables with identical names. We have these green n1 and n2 outside any method and black n1 and n2 inside GetUserInput method. And these n1s and n2s are different variables. Another rule, you cannot have two variables with the same name inside the same scope. But since in our case the scopes are different, we now have two separate variables named n1 and two separate variables named n2. To fix this, we first need to figure out whether we need two sets of n1 and n2 variables, or we should get rid of one. The idea of the GetUserInput method is that it will take the text from the text fields on the form, convert that text into numbers, and then those numbers will be picked up by other methods that will do some math with them. In other words, GetUserInput method must use the same n1 and n2 variables as the addBtn action performed method, and all other event handlers for that matter. So we need to make GetUserInput method use these green n1 and n2. How? Simple. Simple to do, but might not be very simple to understand, so I need most of your attention now.
Now listen to me very carefully.
To have GetUserInput method use the green n1 and n2, we should not declare new n1 and n2 variables inside the method. Instead, we only need to assign values to the green n1 and n2. To make that happen, we just erase int before n1 and n2. Erasing int before n1 and n2 changes the code from variable declaration and initialization to value assignment. Now, if you don't know or don't remember what variable declaration, initialization, and assignment mean, I strongly recommend that you refer to the Basics of Programming with C video series. Finally, we need to call GetUserInput method inside the addition button event handler, and we must call it before we do the math. Otherwise, the values stored in n1 and n2 will not be correct. Now, how do we call a method? Right, we call a method by its name followed by a pair of round brackets with all necessary parameters. Since GetUserInput method doesn't take any parameters, we leave the round brackets blank. Please note that because we're calling a method declared in the same class, we do not really need to use the dot operator. And this method call looks pretty much like a function call in C, as some of you might have noticed. Remember, methods are basically just functions trapped inside classes. Before we run the program, let's further modify the addition button event handler to make the code even shorter. Since we use this result variable only once, it won't hurt too much if we just get rid of it and do the math here with a value of method call. Like this. And if we run the program now, we will see that the addition button still works. Let's now do the same for the remaining 3 buttons. And it seems to be working. Before we move on, let's do a quick recap. So we reduced the amount of copy-pasted code by moving the copy-pasted code to a separate method that we then call in each of the event handlers before we do the math. What we did is called refactoring. Refactoring is changing the code without changing its functionality. Our program still does the same thing as it did before we made all these changes, but now it is structured differently. The way our code is structured now is a bit less straightforward because we have split it up into parts, but it's more manageable now, and I will show you why in a moment. The other issue with our program is that it throws an error when we try to do math with something that's not an integer number. Let's run our program and make it throw the error. If we look at the console, we will see that there is an exception. An exception in Java is a type of error that can be caught. If you catch an exception, you prevent it from happening. To catch an exception, we need to know the name of the exception we want to catch and the method that throws the exception. The name of our exception is numberFormatException, and it's yet another Java class. If we look at the console again, we will see that it's the parseInt method call inside GetUserInput method that throws the exception. So we now know the name of the exception and the method that throws the exception. Let's catch it. To catch an exception, we need to place the code that can throw the exception inside a try block, like this. Then we need to add a catch block immediately after the try block. And in the brackets that follow the word catch, we need to declare a variable whose type matches the type of the exception, like this. So E is the name of the variable, and number format exception is the data type. As was mentioned before, number format exception is a class, and every class in Java is a data type. The name of the variable can be anything you like, but E is a more or less standard variable name for an exception in Java. Inside the catch block, we can place the code that will get executed if the exception is caught. For now, let's have a program print something when that happens. Let's now run the program and see if it works. You can see that now when we type something other than an integer number, NetBeans no longer throws the exception. It just prints error. But again, since we're making a program with graphical user interface, let's not print anything to console using the println method. Instead, we're going to inform the user about the error by displaying respective text in the result label on the form, like this. If we run the program now, we will see that even when we do provide an invalid input, the program doesn't display that message. Why? Let's look at the addition button event handler. Here we call GetUserInput method, which sets the text of the result label to invalid input if we type in something other than an integer number. However, this event handler doesn't know whether the input is valid or not. The way our code is written, when we press the addition button, it calls GetUserInput, and then, regardless of whether the input is valid or not, the program adds the numbers and displays the result in the result label, overriding the invalid input message, so we never see the message. Before we start fixing this, please take some time to make sure you understand the issue that we need to solve. So to solve the issue, we need to change our program so that it does the math only when the input is valid. There are several ways to achieve that. Some of them are more beginner-friendly, some of them are less so. The one that we're going to use is not the most friendly, but it's more in line with the object-oriented programming approach. Also, we're not really beginners anymore as we've learned a lot, so we might as well take a more challenging approach. So what we're going to do is we're going to change the return type of GetUserInput method, and we will have the method return true when the input is valid and false when it's not. Since it's just true or false, what data type should we use? Right, Boolean. So we need to change void to Boolean, and immediately NetBeans is going to yell at us that it's missing a return statement. We used a return statement in one of the previous videos to terminate a main method. However, if you scroll down to the main method now, you will see that there is no return statement, and NetBeans is not yelling, demanding one. Why? A return statement is optional for void methods, but for non-void methods, you must have at least one return statement. At least one means that you can have multiple return statements in a method. Also, a return statement inside a void method is just the word return followed by a semicolon. However, inside a non-void method, the word return must be followed by a legit value whose data type matches the return type of the method. I know it probably sounds confusing and overwhelming, so let me just show you what I mean. Because the return type of GetUserInput method is Boolean, we must return a valid Boolean value, which is either true or false. Let's have it return true at the very end, here. And now NetBeans is not yelling at us anymore. Good. So when the input is valid, GetUserInput successfully converts the text into integer numbers, ignoring the catch block. Then it gets to the return statement, which tells it to return true and terminate. However, when the input is invalid, GetUserInput enters the catch block and sets the text of the label to invalid input. And then we need to have it return false and terminate, ignoring this return true statement. So we need to add return false here. This might be a bit confusing, especially if you don't have much programming experience, and you might feel that it's unnecessarily complicated, but using return statement is a very common programming technique that in fact makes things easier. Now let's get back to the addition button event handler. We now need to change the code so that it doesn't do anything when GetUserInput returns false. Any ideas how we can do that? We can use an if statement, like this. Let's see if it works. And it does. We can make this code a bit shorter by deleting this part. This shorthand form was mentioned in one of the previous videos. Alright, so now let's do the same for the remaining 3 buttons. And run the program to see if it works. And it seems to be working just fine. Before we wrap up this video, let me explain why too much of copy-pasted code is bad using what we did in this video as an example. Do you remember how many changes we made to the GetUserInput method? I don't remember how many, but we made a lot. Now, can you imagine making all those changes 4 times for each of the buttons? That would have been more work for us, but not only that, when we have to make the same changes in the several places, it's very easy to accidentally make a mistake and forget to make a necessary change for, say, the division button. Splitting code into smaller parts might not be very easy to do, and it might be confusing, especially if you're new to programming. But it certainly makes it easier to read and modify such code, especially if you're working on a program that has more than one class. And this is it for this video. In the next one, we'll further modify this program. For example, we'll make it handle not only integer but also floating point numbers. Looking forward to seeing you. Bye.